Okay. Good morning, everyone. We are aboard the RV Falkor, and we're about 50 meters off bottom of the seafloor at 3,630 meters depth. My name is Shauna Gofretti. I'm a marine biologist at Occidental College, and I'm out here with a team of biologists and microbiologists studying the unique organismal life that exists in the Pescadero Basin. And the Pescadero Basin is the deepest spot in the Gulf of California. And these sites were discovered in 2012 by autonomous underwater vehicles, and then we first set eyes on them in 2015 using the ROV Doc Ricketts from the Monterey Bay Aquarium Research Institute. And since then, we have been out with the RV Falkor and the ROV SuBastian team several times to explore these vents. And today we're dropping into a location known as P Vent, and it is a fairly large hydrothermal vent with 200-degree venting water, and the last time we saw it was in 2015, so we're all very excited to see how it's changed and to sample some of the organisms there.
The last time you saw it was in 2015. The last time I saw it was 2017.
The last time Dr. Z saw it was 2017, so he has seen it more 2 years ago. How many?
289.
Okay, so and then in Jenny's paper it's 200 degrees.
Yeah, but that's the good temperature measurement.
Dr. Z amends my temperature to 290 degrees. So it is hot, and it forms these beautiful, what we called fairy castle chimneys. So we'll see if they're still there. I'm pretty excited. I am here with Jared and Ben, ROV pilots, and John is our marine tech this morning, lead marine tech. We're getting close. You'll see the seafloor when we do. Our first objective is to land on the seafloor off target to take a heat flow measurement. So we have collaborators who are studying the tectonics and the sort of heat flow properties of the region. And they're interested in doing heat flow transects and measuring conductivity and heat in the sediments. So we sit here, we have a heat flow probe attached to the submersible on the side that we can't see from the cameras, and they'll be taking a bunch of measurements here. Only takes about 10 minutes. Can you do it all without minute? Yeah. Dr. Z is jack of all trades. Geologist by day, heat flow by night. Don't make any more. Among other things. We're excited to have had these amazing maps from the 2012 expedition and then 2018, where the geophysicists were able to get beautiful resolution, 1 meter maps of the seafloor along with overlaying photo mosaics. And early days of discovering hydrothermal vents, that was unthinkable. You would basically just collect water samples at deep depths and look for temperature and chemical anomalies. And then maybe you would drag a towed camera and look for those sites. And then you would finally use an ROV, and sometimes to no avail, you would search for days for new hydrothermal vents, even though you knew exactly where they might be. So this new technology of these AUVs, of these autonomous underwater vehicles, have really transformed our way of doing science, especially for the microbiologists. We are on bottom. Can I zoom in?
Absolutely.
Look at that beauty. Some sort of stalked cnidarian off in the distance, so probably the focus won't be great, but we'll see what we can do. Can you do it? No. Too much marine snow. There's a lot of marine snow in our field of view here. Umbulula. Umbulala. Hmm?
Yesterday the visibility wasn't great. It seems like
Yeah, no, there's quite a flow. Ah, perfect. Thank you. Nice. You can count tentacles. 8. Octagore. Here's Minute.
Where's Jeremy Horowitz? Usually in the chats by now.
Overslept. So,
White balance real fast.
we are at 3,671 meters in the Pescadero Basin, Gulf of California.
we can use the arm, it's fine.
Doing a little white balancing here so our video is not so green.
Yep.
Nice. Great. How'd you convince it, Jared?
Okay, we're gonna insert the probe.
Okay. Inserting the probe.
Doesn't want to. Let's do it.
Probe going in.
So
Probe
we
is in.
10, 20,
Where's first reading?
35 meters from P-vent or so? What do you think? Yeah.
Yeah.
35 meters.
25? 30?
It's gonna be a hot one.
I
Yeah.
see. 25, 30? Mm-hmm.
Yeah. Something like that. From
Yeah.
the vent?
Mm-hmm.
Yeah.
25. 30, 27. To be exact. Sort of.
Very sort of.
27.
Yeah, I think that's way too many decimal places.
We don't need that many, that's right.
27.52 meters.
Somebody actually wrote a depth like that in the notebook the other day. I cracked up. Like, we don't know. We don't. Let's look at the seafloor.
You usually find all kinds of critters.
Yeah. So beautiful. Look at him down here. This peaceful existence. So beautiful. Most of the microbial biomass on the planet is here.
Well, not right there, but
Right here. Well, Victoria, test my hypothesis.
That's true. Prove it.
That's right. I mean, generally in this area. The subsurface
subsurface.
of the
This
oceans.
still counts too shallow.
Oh, Victoria
Gotta get
thinks this
below-
is too shallow. Well,
below 10, 15 centimeters.
okay, we have to go below 10, 15 centimeters to hit the sweet spot for microbial abundance. And deeper, yeah?
And
Mhm.
below
Beyond.
that is
Mhm.
considered biosphere.
Deep biosphere. Some of our microbiologists on board study those things, those kinds of questions, and they are out here, you'll see soon, to core some of this sediment to measure the microbial community. And then Greg Rouse and I, from the Scripps Institution of Oceanography, we are out here interested in the animal life, primarily at the hydrothermal vents, but also out in the flats here. You'll see a bathymetry overlay now coming into view. This is the Pescadero Basin, and dark blue is the deepest depths there. And that map that you see in the bottom of that basin is our high resolution maps that we were provided by the physics team from Leg 2. And you'll see exactly, this is the Auka Vent Field, and we're coming up from the south here on this map, looking down at, we're passing over Z Vent, which we'll visit later today, and we'll be dropping into P Vent, which is this large structure that you see there. And so these habitats are really novel. We have new species that live at the vents here. So there's about 4 large features and several smaller features, and we did a ecological analysis in 2015, followed up in 2018, and we discovered quite a few new species unknown to science living at these hydrothermal vents. And we've even found a couple in the last 3 days. We'll let Greg tell you more about that. This is another one of those sediment munching isopods that Victoria saw yesterday. That's all I can do. It's not a picnic on it. Yeah, so the Pescadero Basin is unusual in that the hydrothermal vents are made of calcium carbonate and not your typical hydrothermal vents, and of course the physical and chemical characteristics of the habitat control the distribution of animals especially. And so we weren't completely surprised to see novel organisms here, but what was surprising is that they are unlike the animals found in the Guaymas Basin to the north of us, and they're unlike the animals found at the Alarcon Rise to the south of us. So really a localized and unique community.
Yeah, while we're driving in, we can maybe look for some more species.
Yeah, it doesn't look quite like it did down south in terms of the qualitative xenoland.
Anything on that?
Yeah. Let's see. I don't see the ruffles. Maybe.
A lot of sea cucumbers around.
Yeah. We only have the sea cucumber, we have a very specific one we can collect, otherwise we can't collect any others. They are, the Mexican government is very concerned about some of their sea cucumbers and over-harvesting. It's not really our main objective, so we leave them alone. Yeah, I don't know, Victoria, didn't look like one. Let's look at the sea cucumber though. So cool. Can you imagine having feet on all around your body? They have 5 rows of feet here. We've got some 2 feet that are sticking up in the water. Yeah, whatever. We'll watch this sea cucumber consume the seafloor. I'm sure they've done estimates on how much sediment
the seafloor has gone through the gut.
Been pooped out by a sea cucumber. It's probably a lot. And how
We can get
often?
Rob Phillips on that.
Yeah.
By the numbers.
Every 5 days, all sediment goes through the gut of a sea cucumber on the seafloor. That's my hypothesis. Test that one too. Some numerous rows of tube feet. No tentacles though. Taking a nap.
Made an abundance estimate.
Those are not anemones, those are worms, so yes.
What's that?
Those
are
what's this?
probably infrared. So.
Yeah,
That's an infrared.
yeah. We were talking. Yeah.
Okay, we're good.
We're good.
Pro coming up.
Good minute. Thank you guys.
Looking at the polychaete. Mouth open, living in a burrow.
Yeah.
Alright, here we go. Happy with that? We're going to make our way?
ROV is out.
Alright, let's make our way slowly to P Vent. We're going to look for those giant protozoans, the xenophyophores. Somebody said, is it cool or is it hot? We think it's going to be hot. We're only 30 meters from the vent, so.
Okay.
It's hot? So we have our collaborators who are telepresence with us here, and so we send the data from the submersible back to shore. They crunch the numbers and then they send it back to us and tell us what the calculations are. And for some temperature measurements, obviously we know right away, but for heat flow, we need them to process it. And we have a Slack channel open for that dialogue, which happens pretty quickly out here. I see little clams making some tracks. That looks like an Oasisia abandoned tube. Do you need my camera to drive, Jared?
If you want to take it,
Okay. Oasisia tube. Some live clams in the sediment there. Oh. Could be Coryphaenoides here. Do I have iris control? Let's see, I can't tell. Okay, it should be dead ahead. Yeah, so I see some features here. So we're coming up to the scarp. We're coming in from the north.
Okay, so it's only like 30, 40 meters.
Yeah, it's smaller than Z-Vent. All right, what are these? Tunicates?
That looks similar to what was on this. Oh no,
There's a ctenophores. Are these the benthic ctenophores like we saw over on?
No.
I feel like they're tunicates. Yeah.
Which we also saw on the ctenophore
This
wall.
is I think that's the U-shaped gut of maybe. No, the ctenophores on the wall were smaller and had those long sticky
I thought there were
tendrils.
tunicates over there too. Maybe not.
Maybe I have. I don't think I still. Oh wait, no, I do have control.
That's somebody different right
Yeah.
there.
Yeah.
Hang on.
Looks like a jelly.
Sean, if you still have ours,
I do. Yeah. This flowery looking creature in the. Oh, it's.
Do that at work to get you.
That's my zoom.
Cue.
Here comes Greg.
Rouse.
Runs in. She knows to sniff out a new invertebrate. Whoops. Want me to?
I can get in there for you, and then we can.
Sure. Yeah, I'll back up. Yep.
Kind of a recent looking.
Look at all those, Greg.
Do you think so?
Yeah,
In the back?
With the white cows, yeah, I think so. It's sedimented, so it's not real recent. But
All right, go ahead.
Anemone.
oh, it's a daisy.
Looks like a different kind.
Yeah. Oops. I'm so sorry.
Two of them.
Yeah. We're flying.
You're good.
We're off bottom.
I'll come in too.
No, it's all right.
One thing, if you wanted to, you could mark the location if you,
Uh-huh.
you know.
Well,
You can
I
always
mean,
come back if it turns out to be an
Yeah.
interesting thing.
and
And there's
then
this little, you see little white polyps.
let me come and look.
Like free texts. Like, there's a box where you can enter shirts.
John, I actually don't have Iris or Ben.
Just go over the Seafloor.
Hmm?
You want to look at the tunicates?
Ben, you mind putting auto on both the iris and ISO, please?
They've got somebody living in there.
And then
Look at all those little flecks. Amphipods, yeah.
Let's see, is it predatory kind?
try that.
I can't tell. No, still no.
I'll try it.
No?
And then you can take it out of auto.
Let me go down and look at these. There's a bunch down here. They don't look like the predatory kind because they've got. Nope, still no. Sorry.
Take the focus back down.
There we go.
Yeah,
got it.
fix it. Nice. Thanks. It's the digestive system, yeah, Greg?
Yeah.
Mm-hmm. U-shaped.
Interesting.
The stalk is very. Yeah.
You've got the inhaler and the exhale.
Mm-hmm. Yeah, exactly.
It's not got the big mouth like
Right.
regular Nairobi, I guess.
That's what's weird. They're on stalks, but they have their big segments. Beautiful octocorals. Neat little critters. Okay, we can move on. Carl's eating M&Ms for breakfast. Just if anyone wants to know. Our diets get a little weird out here. We're getting great food, but still,
Says the woman who declared candy corn
as a breakfast item. That was special for Halloween. Candy cornflakes, we decided, was a breakfast item. Look at all these Oasis tubes. They're probably raining down. They're just abandoned tubes here. All right, let's go see it. Any ideas for coring yet? Probably not, huh? Oh, so much in the water column.
Yeah.
Marine skunk. Mm-hmm. Yeah, it's neat. All right, just 10 meters from the P vent. Make our way. It's beautiful.
Ooh.
Another one of those giant anemones. Giant. That saggy one looked crazy yesterday. Yep, same. Okay, we're gonna.
This mountain's falling apart. Like,
Yeah, it's
big
really falling apart.
Interior.
Big chunks. As it's being built up, it also crumbles to the sides, creating these big mounds. John. What was that, Carl? There's a magically self-filling candy cabinet covered with snacks. All right. Let's look.
They let us snack out.
Snack
It's
out.
basically health food. It's got antioxidants, peanuts,
Protein.
protein.
Peanuts are actually the same, like macros wise, as steak.
Oh,
So that's what you're really.
instead of